Welcome to the Basics tutorial. In this tutorial, we demonstrate the loading of projects, image enhance, photo properties, the quick referencer, editing a project, additional zoom tools, tables, object properties, surfaces and textures, processing, the measure tool, and toolbar customization. First, we will load an existing project. We will continue working with the project that was created in the first tutorial. We click the Open Project button from the toolbar and browse to find box2.pmr. This project continues where box1.pmr left off in tutorial 1. We select the file and open the project. We open Photo 1, maximize, and zoom to fit. Here we will introduce some new tools to help us work with photographs. This first tool is called Image Enhance. It is opened by selecting Image Enhance from the Edit menu. This brings up the Image Enhance dialog. We move the box so we have a better view of the photo. When an image is too dark or too bright, it can be difficult to view and accurately mark the features. Image Enhance lets us adjust the contrast, brightness, and gamma of the images using the slide bars. Contrast adjusts the difference between bright and dark. Brightness adjusts the overall intensity of the image. Gamma is useful for making parts of an image visible that normally may be hidden in shadows or overly bright areas. Reset returns them to the original settings. Any enhancements we do make are saved by PhotoModeler. For example, we make adjustments of contrast, brightness, and of gamma, and click OK. The photo is updated to show the changes. If we close the photo and reopen it, the enhancements are still there. However, this does not change the actual photo file. The enhancement settings only affect the view of the image in the photograph window. We can hit Reset in the Image Enhancement dialog at any time to return the photo to its original state. Next, we will look at a feature called Photo Properties. We right-click over Photo 1 and choose Photo Properties. The Photo Properties dialog box provides some information particular to the photograph. In the Camera section, it tells us which camera was used to take the photograph. For the projects where there are 2 or more cameras used, this section will be used to assign the correct camera to the photo using the drop-down list of available cameras. In this project, there is only 1 camera used. The processing action gives you control over how you want the photograph used in the project. The default is Use and Adjust. In the description box, a text name is assigned to the photograph. This is the name that appears on the photo title bar, and the default is taken from the image file name. The description can be changed at any time. The Camera Station section provides position and angle values for the solved camera stations. The camera station is the position of the camera that took this photo. It tells you if the photo has been oriented. The Force Unoriented button can be used to return the camera station to an unoriented state as if it was not processed. This is mainly used for troubleshooting purposes. The Inverse Camera section refers to some options used in an advanced feature called Inverse Camera. This will be discussed in a later tutorial. Texture Setting is used to provide photo quality settings. This is used to tell PhotoModeler which photos in the project have priority for textures to be extracted from. This is described in the help file. This last part is Photo Rotation, which allows you to rotate the photo so it is easier to work with. For example, if you take a photo of a building in Portrait, then bring it into PhotoModeler, it will appear as if it is lying on its side. Photo Rotation allows you to rotate the image so it is easier to view and mark features on. To demonstrate, we click the 90-degree option and click OK. The view is now rotated 90 degrees. The actual image file is not rotated or modified, and the photo can be returned to its original view by clicking None in the Photo Rotation section of Photo Properties. It is important to note that the photos for use in your PhotoModeler project should not be rotated or modified before they are imported. They should be imported in the exact same way that the camera took them. Next, we will look some more at the editing process. We zoom in on Photo 1. In Tutorial 1, we did some editing by selecting and moving points into better positions. Another editing tool is the delete function. Once you mark a point, it can be removed from the photo at any time. If we decide we want this point deleted, we select it using the Select tool and select Edit, Delete Selected Items, or we can press the Delete key on the keyboard. The point and any connected lines are deleted from the photo. If we decide that we don't want that point to be deleted, we are able to undo the most recent action. We do this by clicking Undo from the toolbar, or by selecting Edit Undo. The point and connected lines are returned. Undo applies to other actions as well. For example, if we move this point, then decided this wasn't what we wanted, Undo will return the point to its previous position. Delete can also be used to delete other objects such as lines. We select this line, delete it, and the line is removed from the project. We undo the delete. We can delete multiple items at the same time by using Select and the Shift key. We select these three lines, delete them, and the lines are removed. We then undo this last action, and the three lines are returned. Next, we will add some new points to the project. As shown in Tutorial 1, new data such as additional photographs and points can be added to a project at any time. We pan the photo for a better view. Then use the Point tool to mark these 4 corner points along this picture on the front of the box. We use Select and the Alt key Zoom to adjust the point positions. We open Photo 2, maximize, zoom in, and mark the same 4 points using the Point tool. We use the Alt key Zoom to adjust the points. While within the Alt Zoom window, we can pan the photo by moving the mouse. This gives us easy access to the other points that are nearby without having to leave Alt Zoom mode. Next, we will reference the newly marked points between the two photos. In the first tutorial, we used Reference mode to reference points. In this case, we will use the Quick Reference tool. First, we tile the two photos and select Zoom to fit all. We select this point on Photo 1, press and hold the Shift key, and click to select the matching point on Photo 2. We then click the Quick Reference tool, and Photo Modeler references the 2 points. We can check this by using the Mark settings from the Photo Control sidebar. We click the Point IDs box. Each point is assigned an ID number as shown on the 2 photos. Points that are referenced will have the same ID number. We can see that the 2 points we just referenced have the same ID number, while the other 3 points that have not yet been referenced all have different IDs. We select Shift and use Quick Reference to finish matching the points. Quick Reference is useful when doing a small number of points, while referencing mode is more appropriate for referencing many points. Next, we will use the Line tool to connect the 4 points. We then view the results in the 3D viewer. We open a 3D viewer with points and lines turned on and use the controls to view the model. The newly marked and referenced data appears in 3D. You may have noticed that we did not process the project after marking and referencing the new points, but they still have calculated 3D positions and appear in the 3D viewer. The reason is that the points were marked and referenced on photographs that have already been oriented. Oriented again means that Photo Modeler knows where the camera was when the photo was taken. Photo Modeler uses an algorithm called the intersection algorithm to automatically compute newly marked and referenced points on existing oriented photographs. We can still reprocess the project if we like. The new data will be used in the calculations that determine the overall accuracy of the project. We close the 3D viewer, turn off point IDs, click the Photos tab to display the docked photos, and maximize the Photo 1 window. Next, we will look at some additional zoom tools. The plus key on the keyboard can be used to zoom in on a photo. While in select mode, we move our mouse over this point area and press the plus key. This zooms in on the photo. Similarly, pressing the minus key zooms out of the photo. These are useful tools because you can use these zoom tools without leaving the current mode you are in. For example, if we use the point marking tool, and we want a closer view, if we use the zoom in tool from the toolbar, the mode changes to zoom in mode. We can then zoom in, but we have to select the point tool again from the toolbar to reactivate that mode. If we use the plus button, we can zoom in without leaving point marking mode. While we are still in marking mode, if we right-click over the photo, we have another way to access to the zoom functions. Zoom to fit, which we have used before, returns the magnification of the photos so that it fits in the window. Zoom 1:1 zooms so that 1 pixel from the photo matches 1 pixel on the screen. This is the true size of the photo and will sometimes be too large to see fully on the screen. Zoom previous goes back to the previous zoom. And the zoom in and zoom out tools can also be accessed in the right-click menu. All the right-click zoom tools work without leaving the mode you are in. We have already demonstrated the Alt key zoom tool, which is accessed using a keyboard button. Another powerful zoom tool accessed from the keyboard is the Control key zoom and pan. This is used by pressing and holding down the Control key, which brings up the special cursor. We select an area to zoom in on by left-clicking and dragging. With the Control key still held down, we can then pan the photo by using the right mouse button and clicking and holding to drag the photo within the zoomed window. When we let go of the Control key, we return to the mode we started in. We have shown a number of different ways to access and use the zoom modes. These are used very often, and you have the choice of using the zoom tools you feel comfortable with. We have previously viewed the results of the 3D model using the 3D viewer. Another way of viewing the results of the project is through tables. PhotoModeler includes a number of different tables to view project data. First, we will select the photo table from the table drop-down list. This brings up a photo table with columns showing various data. Each row represents a photo in the project, and the columns displays its information such as the photo number, image chip, description, processing information, orientation, and image size. Using the scroll bars, we view more columns such as the project camera, focal length, number of marks, and number of reference points. A row can be selected, then with a right-click, various actions can be taken. These options vary depending on which table you have open. A column heading can be selected to sort the contents of the column by increasing or decreasing order. This top area of the table contains tools that allow us to configure what information the table's columns contain. We can also view the properties of the selected row or export the table data in text format. We close the photo table and open a point table. There are a number of configurations for the table as shown in the drop-down list. Each table configuration has a different set of columns. The basic configuration displays data such as point ID and XYZ coordinates. If we select coordinates, this configuration only contains the XYZ coordinates of points in the project. The quality configuration is very useful. It displays information about point quality such as precision and tightness. We use the scroll bar to view some of the other columns. These are all very important when studying the accuracy of a point and the overall accuracy of a project. We can sort the data in the columns by clicking on the heading. By sorting of largest residual using decreasing order, we can see which points are in most need of improvement. If we choose the All configuration, this displays all the point information available in table form. We use the scroll bars to view the different columns. We can click the Configure button to change and add configurations. We can view the current list, delete them, change the default configuration, add new configurations, change the order of columns, and add or remove columns that are displayed. We can also change the view of the table right within the open configuration. We can adjust the width of any column by dragging a column edge. We can change the order of the columns by clicking and dragging a column to a new position. For large tables that would contain many rows and columns where you have to navigate by scroll bars, we can split and duplicate the table. For example, in a table with lots of columns, we drag on the edge of the scroll bar, unclick, and the table is split. The tables contain the same data, but we can view different columns in each of the tables. A table can also be split horizontally so different rows of information can be seen. This can save time by not always having to scroll to see the data you want. To return the tables to a normal view, we simply drag the edges back. Those are the basics of using tables. The same concepts can be applied to other available tables for surfaces, curves, edges, and cylinders. Previously, we looked at photo properties accessed by right-clicking over a photo. All objects in Photo Modeler, such as points and lines, also contain properties. We close Photo 2, maximize Photo 1. Select this point on Photo 1, right-click, and choose Properties of Selected. We can also access Properties of Selected from the toolbar. Each object type has different properties. We have selected an object point, and it has the properties of a point ID and a username, which is blank by default, but a description can be added at any time. We will add a description called TopBox1. The XYZ coordinate position information is displayed in the units of centimeters. This checkbox offers the option of whether the point should be used in processing. This option can be used to set the point to a frozen position. This will be discussed further in a later tutorial and in the help file. We click OK to close the Properties box. We then click the Mark tab from the Photo Control dialog box and turn on Point IDs. We can see that the new point description is displayed on the photos with the ID number. Next, we select a line and choose Properties of Selected from the toolbar. Lines do not have many properties, just the material, which is the white default material, and the layer, which is also at the default setting. The Items tab displays what items are selected for viewing properties. We can select multiple items and choose Properties of Selected to view the properties for all those items. Here we select 3 lines, and the properties show that we have selected 3 lines. And the material and layers are the same for each. Next, we will work more with materials and layers. We close the Properties dialog and select these lines from the front of the box. The material and layer properties also appear here in the toolbar, allowing them to be changed quickly. The selected lines all have a white material. We will now change this. We click Open Materials dialog from the toolbar. Every project begins with 2 materials, one called White and one called Surface Default. White is a fixed material with a red, green, blue color setting that cannot be changed. Each color setting is at 255, which results in a white color. RGB settings can range from 0 to 255. All lines and points get this material by default. Surface Default is automatically applied to surfaces and is set to multi-photo textures. Unlike the default white material, this material can be changed. Next, we will add a new material. We click the Add button and type in a name of blue. From the color picker, we select a medium blue color and click OK. The red, green, and blue settings are shown for that blue color. We click OK, and the new material is created. This does not automatically assign the selected objects this new material. To give these selected lines the blue material, we choose Blue from the Material drop-down list. Photos do not show object materials. The materials correspond to 3D objects only. So we open a 3D viewer. We leave points and lines on and click OK. We can see that those lines now have a blue material. Material settings can be applied to any object such as points, lines, curves, and surfaces. The other item to look at is layers. All objects in photomodelers are in layers. This is similar to the CAD concept of layers. This is a way of grouping objects together. Every project starts with a default layer of which all objects are put into. We will add a new layer by clicking the Open Layers dialog from the toolbar. We click Add, and add a new layer called Front Lines. We click OK, then select the 4 front lines in the 3D viewer, and choose Front Lines from the Layers drop-down list. Now when we select any of these lines, they are shown to have the Front Lines layer and blue material. Where layers are helpful is in large projects with many objects that make it difficult to study and view particular parts of the model. Layers can be turned off so they are not visible. For example, we do not want to view the Front Lines layer on the photo. We maximize Photo 1, and in the Marked tab of Photo Control sidebar, we turn off the Front Lines layer from the Visible Mark Layers section. The lines are not visible on the photos. We can do the same in the 3D viewer. We open the 3D viewer window. Go to Options, and turn off the Front Lines layer in the By Layer section. We click OK, and the 3D model appears, but the front lines are not visible. This does not delete the lines from the project, it just makes them invisible. Visibility can be turned back on whenever we choose. Here we will go back into 3D options, turn off points, turn off the default layer, and turn front lines back on. We click OK, and all that is visible is the front line layer. We return options back to normal settings. Materials and layers are useful for viewing and studying sections of a project, and are valuable when exporting models for use in CAD and graphics programs. Another way to change properties of objects is through the Property Changer. This is accessed by clicking Edit, Property Changer. This dialog provides a number of options for choosing which objects we want properties changed for. We can make changes to selected objects, to all objects in the project, or to particular types of objects such as points and lines. Here we will change all 3D lines in the project. We notice that the material and layer lists are blank. This is because some of the lines in the project have the white material while others have the blue material. This is the same case with the layers. Some of the lines have the default layer while others have the front line layer. The material and layer lists cannot list more than one, so they are left blank. What we will do is force all lines in the project to have the blue material and the front line layer. We click OK. The 3D viewer now shows that all 3D lines display a blue material. If we select a line, the toolbar shows the front lines layer and blue material. Next, we will take a closer look at surfaces and textures. First, we will save the project as box3.pmr. In the 3D viewer options, we turn on surfaces only with the shaded option. We review the model, then turn on Fast Textures from the Options dialog. As we demonstrated in the first tutorial, these textures look distorted due to perspective and can be corrected by using the Quality Texture setting. We select one of the surfaces, and we can see that it has the surface default material. We open the Materials dialog to see how this material is defined. Surface default is defined as a multiple photo texture. extracted from all photos in the project. This means that PhotoModeler decides which photograph is best for use in texturing based on the positions of the photographs and the orientation of the surface. We can also tell PhotoModeler to use textures from a particular photo. We add a new material and call it Photo 1. It will use a single photo texture, forced to Photo 1. Any surface that is assigned this material will grab its texture from Photo 1. We will test this by changing the material of the selected surface to Photo 1. We can see that the appearance of the surface changes. For another test, we select the bottom surface. This surface does not even appear in Photo 1. But we will change the material anyway. The 3D viewer updates as the surface grabs the texture from Photo 1. It is clearly incorrect, but shows how PhotoModeler can be told to assign textures. We change the material back to default for this surface. Next, we will look at Advanced Material Properties. We open the Materials dialog, select Surface Default, and click Advanced Material Properties. The specular, emissive, and shininess colors are useful when exporting materials for use in advanced graphics programs. The photo texture settings tell PhotoModeler how to pick which photograph to use for a particular surface. This setting tells PhotoModeler that a surface has to point at a photograph within 80 degrees for that photograph to be used. At 90 degrees, the surfaces cannot be seen in the photographs, and this results in poor textures. A lower value means that PhotoModeler will choose photographs that are pointing more to that particular part of that surface. If there are no photographs in the project that meet these criteria, PhotoModeler will use this color instead of a texture and apply it to that surface. For some objects that are symmetrical, we can try flipping the surface 180 degrees, and it will pretend the surface is facing 180 degrees away. The multi-photo texture control is used to decide how to choose which photograph in a set is the best choice to use for texturing. We close this dialog. When photo texturing a model, it is best to start off using the default surface material, which uses multi-photo textures from all photos in the project. If there are particular parts of the model that you think could be improved if a different photograph was used as the source for the texture, then you can create a new material that forces a surface to take textures from a particular photo, such as Photo 1. Or you can change the settings in the Advanced Materials Properties. Next, we will work with a feature called projections. These are accessed from the Photo Control sidebar. We have been using the 3D viewer to look at the 3D model. Projections are another way to study 3D data. They are a view of the 3D model projected back onto the photograph. We close the 3D viewer and view Photo 1 open, maximized, and zoom to fit. In the Mark tab of the Photo Control sidebar, we turn off points and lines. This makes them invisible but does not delete them. Next, we click on the Projected tab and turn on lines. The 3D blue lines are projected onto the photograph. The projected lines allow us to see how well the model has lined up. We use the projection settings for a better visual. We change the line thickness to 2 and adjust the transparency so the projected objects appear more solid. We go back to the Projected tab and turn on Surfaces. We see the solid 3D surface of the object projected back onto the photo. We turn projected lines off and increase the transparency in the Settings tab so we get a better view of the 3D surfaces and how well they line up with the photo. We turn off Surfaces and click Lines again. We zoom in for a closer view and study how well the projected objects line up with the features on the photo. Projections are very useful for checking accuracy and viewing how well a project has solved. They are also useful when doing particular types of projects that involve external control point data. We turn off projections and turn point and line mark data back on. Next, we will take a closer look at the processing dialog. We went through processing rather quickly in the first tutorial, but we will go through the processing dialog in more detail here. The dialog box is split in two. The left side displays information and provides options as to what steps are involved in processing. The steps are orientation, which determines where the cameras were when the photographs were taken. The global optimization stage is used to fine-tune the calculations and reduce error. There is also a self and field calibration stage that can be used in projects to improve accuracy when the project is set up correctly. The Options tab provides us with some control options. Since the project has already been oriented, it does not suggest that orientation needs to be done. We can force it to reorient and process the project from scratch by selecting this box, and the Orient All Photos option. Global optimization can be turned on or off. Usually it will only be turned off for use in troubleshooting. Process constraints is applicable for projects that are using constraints, which will be discussed later. On the right side of the dialog box, we are provided information that tells us how well processing will run. Audit Overview provides information such as total number of 3D points and photos in the project, and it tells us if it thinks these numbers are acceptable for processing. We get a Maybe rating. This is due to the low number of 12 points and 3 photos. A typical project will have higher numbers than this. In this section, it provides a summary as to how it rates the points and photos. It says 7 of the points are weak. This weak rating is given to points that only appear on 2 photographs. Points that appear on only 2 photographs tend not to be very accurate. 1 photo is rated weak, based on the criteria of camera station angles. The Audit Photo tab provides information about how many points there are per photo. The ratings will be more positive as more points are added. Photo coverage refers to how much area the photo the marked data covers. If it is a very low percentage, this can lead to inaccurate results. The Audit Summary provides a rating for potential accuracy. This project is given a low rating of 2 due to the low point count. This does not necessarily mean the result will have low accuracy, but this is a prediction based on the point and photo data. In this section, suggestions are provided to help us improve the project. In this case, it is suggesting that we add additional references to points. We click the Process button, and it processes successfully. We click the Show Report button. This brings up the project status report. This provides various information such as total error and quality. The most important data to look at is in the Problems and Suggestions area. It lists one potential problem, which is that the camera we are using is not calibrated. Depending on your project needs, a calibrated camera may not be necessary. We set up our project using the Camera Setup Wizard, and for many projects that is sufficient. For projects that require higher accuracy, then a camera calibration should be done. This will be discussed in another tutorial. You can expand and retract the status tree to view the information you want. Some of this information, such as point marking residuals, will be discussed in the troubleshooting tutorial. We click Close, then OK to shut down the processing dialog. PhotoModeler is a tool for 3D modeling and measurement. In this section, we will demonstrate the Measurement tool. We turn the Front Lines layer back on so we can see the lines. We click the Measure tool, and this opens the Measure toolbar. Using the Measures tool cursor, we select this line, and the Measure toolbar displays its measurement information. We can measure any object either in a photo window or in the 3D viewer. As we select this line, we are told that its length is 19.865 centimeters. If we select a point, we are told its XYZ coordinates. If we select 2 points using Select and Shift, it will provide the distance between them. If we select 1 point and 1 line, it provides the closest distance between them. There are many more types of measurements that can be done. These are listed in the help file and user manual. The status bar also provides information about objects that are selected, whether using Measure Mode or Select Mode. If we select a point, the status bar displays its XY position, its residual, its point ID, its tightness percentage, and the photos it appears on. If we select a line, the status bar displays which points the line is connected to, its material, and its layer. In the tutorials we have worked through so far, we have become familiar with the PhotoModeler user interface and particularly the use of the toolbars. In this section we will look at how we can make further use of the toolbars and customize them. We will continue using the Measure tool to demonstrate working with toolbars. Normally the Measure toolbar will appear up here in the main toolbar area. We are also able to move the toolbar to a floating location. For example, we want to measure an item in the photo and have the results displayed near the selected object. We do this by moving the cursor over to the edge of the toolbar, then clicking, and dragging it over to the region where we are doing measurements. The results are displayed in the floating toolbar. We can also move the toolbar so it appears below the status bar on the PhotoModeler screen. We can always return its position back up to the main toolbar area. To leave measurement mode, we go into any other mode such as Select, and the measurement toolbar is hidden again. Any of the toolbars can be moved to different positions on the PhotoModeler screen. We can move the Modes toolbar over to the sides, where it is displayed vertically. Or we can place it in a floating position, or at the bottom, or return it to its default position at the top. Different toolbars can be opened and closed by right-clicking over the toolbar area. This brings up a menu which shows which toolbars are currently open. Currently the Standard and Modes toolbars are open. PhotoModeler has other toolbars that are already created, and we are also able to create our own custom toolbars. We choose the Tables toolbar and it opens in the main toolbar area. We can then select any of the icons to access the tables. This toolbar provides the same access to items listed in the Tables drop-down menu. We right-click again over the toolbar and select Surfaces. The icons for the surface features now appear on the toolbar. These are the same features that can be accessed through the drop-down menu. Again, these toolbars can be dragged to different positions in the screen. We right-click over the toolbar to close surfaces. Then bring up the instruction bar. The instruction bar is placed on the bottom by default. This bar provides step-by-step instructions as you are performing certain operations. This is helpful when using advanced features in PhotoModeler. We close the instruction toolbar and choose Customize Toolbar from the right-click menu. This brings up the Customize Toolbar dialog. Customizing is useful if you find that a feature that you use often is not included in any of the existing toolbars. For example, we use Tile and Zoom to Fit All quite often, but they do not appear in any of the toolbars, and we can only access them through the Window menu. To add them to a toolbar, we choose the Commands tab, which contains all available commands that are listed in all the menus. We find the Tile command under the Window category, then select and drag it to this position on the toolbar, where it is now available for easy access. We do the same for Zoom to Fit All. Similarly, we are able to remove items from the toolbar that we don't use often. We do this by selecting the icon, in this case the cylinder tool, and dragging it off the toolbar and unclicking. We close the Customize dialog. We open a second photo and click the Tile and Zoom to Fit All buttons from the toolbar. The windows are tiled and zoomed quickly using our new toolbar icons. The customization of the toolbars offer us a convenient way of quickly accessing the items we use most often. Menus can also be customized similarly. This completes the Basics tutorial. We have worked through the basics of PhotoModeler interface, tools, features, and concepts including loading projects, image enhance, photo properties, quick referencer, editing a project, additional zoom tools, tables, object properties, surfaces and textures, processing, measure tool, and toolbar customization.